during session 1, we had a few different talks on databases led by Tomasz Budavari. We're going to now just do a quick few exercises on databases. So I'll remind you briefly of some of the big points that he raised during his lecture. And then we have a few problems to just review what we learned during that time. It's something we've seen a few times now. OK. So as I just said, we learned about database operations and how we write queries, maybe even developed small scripts in SQL. So we're going to review some of those basics. OK. So at the most basic level, the way to think about databases is that they store your bytes. However you want to compose those bytes, they store your bytes so that later on you can retrieve those bytes in whatever fashion that you want. Okay, they provide a very highly efficient means for filtering your bytes, and there's many different strategies you can use to retrieve your data from the database. I'm going to pause for a second. I'm realizing, is this font way too small? You guys should all have the notebooks on your laptops as well, but all right, no one said no, so I'm going to continue. All right, the back end for most databases is the structured query language, or SQL, all right, which is a standard declarative language. And there's many different libraries that you can use to implement SQL, MySQL, Microsoft SQL Server, Postgres, etc. All right, so today we're going to start by introducing something we didn't talk about last time, but it's a powerful tool for you to know about, especially if you're dealing with smaller projects, which is something called SQL Lite. Is it SQL Lite or SQLite?
SQLite.
SQLite is the proper pronunciation? OK, sorry. SQLite. All right, so this is a small, self-contained database engine that allows you to basically just build a database right on your laptop. So you have a single database file. You don't have to do any of the complicated stuff, such as setting up a server, which is required for almost all of those other libraries I mentioned a second ago. All right, so first things first, in your notebook as you're following along, let's begin by importing SQLite. OK, so I'm not going to go too much into the weeds for exactly what's happening under the hood here. We'll talk about this a bit more later in the week. But to interact with this database, we need to first establish a connection with that database. All right? And then from the connection, we're going to create a cursor. Right? And the cursor is going to allow us to write queries, update data, have the actual interactions with the database. OK? So if we move to the next cell, I'll go over the syntax here. So we create a variable called conn, C-O-N-N, which is just SQLite3.connect. And if you don't have an existing database and you pass in the name of a database here, it's automatically created. All right, so that's what we're doing in the first line of the code here. So we're creating what we're calling ReIntro.db. All right, so that creates that database. And then we're going to create a cursor by calling conn.cursor. Right? And the cursor is how we're going to interact with that database. Yeah.
Presumably, if there's already a ReIntro.db, does it just connect to that database?
Yes. So now that we've created ReIntro.db, if you open up SQLite again and you call the same thing, you'll just connect to the existing database. Okay. And you now also will have a file on your local directory called ReIntro.db. So we'll learn a bit more about this, I think, later this week. But one thing that's nice, it's also potentially dangerous, but one thing that's nice about this is that since you have a single hard file that's your database, you can actually share that with, say, other people that you're collaborating, or you can easily transport it from one machine to another. Whereas if you've set up a server, that's not as easy. Now, that can also lead to corruption, right? This is not a perfect solution. I see some grimaces in the back row, right? This is not always great, but this is nice for our purposes. We have a small data set we're going to be dealing with right now. Okay? All right, so we've created a new database, like I just said, where we're going to be able to store bytes and retrieve bytes. All right? Unlike, I already said this, unlike most libraries, you don't have to set up a server. Okay? All right. OK, so now that we have a database, we want to create a table. Right? Tables are typically how we store data in there. And we need to insert some data into the table that we are creating. Typically, this is done with a cursor and the execute command. So essentially, anything that you might write in SQL, you can call by saying cur.execute and then the command that you want. Okay? So recall that if you're creating a new table, you need to specify the name of the table, the columns in the table, and the data type for each column. Right, this is an important part about SQL. And so here's an example of a table that I am creating in this database. You guys won't do this exact same thing. But I'm creating a table called pet info So it's going to be a table that stores information about my pets. All right, and it's a table that has 4 columns: name, the name of the pet; species, the type of the pet; age, and favorite food. And then in each of those columns, I'm also declaring the data type associated with that. Okay. Most of these are going to be text entries, except age is going to be a small integer, because I don't expect to have any pets that live to exceedingly large numbers. Okay. All right. So now we get to our first problem. In your database, I would like you to create a new table called DSFP students, right, with the following columns: name, institution, and year, where year is the current year in graduate school. Okay, and we're going to start just by creating that table. Okay, so I'll pause here for a minute. If you need an example, right, there's the example of the pet info table. You can more or less just copy that and change out the appropriate variables, and I'll walk around as well if you have questions.
Oh, that's okay. Take your time.
Get on.
I will have to do that later, but they're very fast. So then save that wherever you want to open it up.
Same issue.
Okay, so we're going to start. We'll get you up and running on GitHub later. For now, we'll just get the file on your computer. Oh, do you already have it? Okay, and then you have. So basically, if you just open this now, as a Python notebook, you should be able to.
I found it previously. I just didn't realize I should actually clone it, so I stuffed it in.
Tiny hints, how high is
I really don't want to.
Yeah, so this week they want all of us to use Python 3, which is different from me. Yeah, I haven't.
I think I have it because I usually work on Python 2. So I have actually changed over to just Python 2.
This is like a new thing I'm doing as of maybe 2 or 3 weeks ago. I'm doing all my homework in Python 3, but in my research work is way too reliant on like other people when they're all using Python 2.
Oh yeah.
I just don't want to do that and
When you
change
just
everything.
just type in SQL query into Python.
I don't have like parentheses around my statements and things.
I hope that worked.
So I don't know about texted.
So then if you, now to get, because I did it the first time,
I used tiny ant for it. I used tiny ant for like data for age.
Oh, my brain read the wrong word.
That's kind of what I was wondering.
Yeah.
I'm sure it would be really.
What's wrong with you?
Well, I think what would
Is
happen
it?
is like
Oh, okay.
Because it already exists.
a function that was like
Oh, weird.
put data in this
Yeah, so I don't know if you can like
and then you can just load it
table
or
and then just make it.
create the
It
table.
doesn't want to create the
Call
table
that
again.
function for each line that's the and so
Okay, wait.
I mean, it's just
There might be a way to delete it and rename it or something.
Oh, sorry, here, sorry, I guess my ears are plugged up too. Second, space like here's back.
And you can also do this with just like starting. Yeah, it's actually just probably just like boiling because you could even like this. Yeah, or you could just like fill in like S and then like name or something. Like just.
Or we could just change the name.
Yeah. I just have to remember it later.
Or IPython notebook. So how do I?
When you're in the folder, when you
I wonder
download
if it's just delete table.
you should, if you haven't done it, you need to keep
I wonder if I've run it now.
So, close the go to any directory you want to go, then git clone and get the address of where you want to clone from the GitHub page.
Okay.
and then open the notebook in that directory.
Got it.
Oh, so 2018 is not yet because
Wait, that
was
is not what should be.
So what should I do?
the year is year in graduate school. Should be your A1 year.
Actually, then here, go.
Oh, okay. That's the.
And then just do a control, and then just copy that.
Actually, if you have your terminal open, it's just safe for your computer.
Yeah, so it should work.
Actually,
Okay.
delete it.
All right.
Thank you.
Yes.
All
Alright. Okay, so I think, oh, sorry, Eve, you had a question?
I'm okay.
Okay, alright, so I think everyone got it to the creation of the table. If you didn't, I've got the solution up here real quick. Okay, so just cur.execute, this looks just like the example from before. Create table, DSFP students, name, that's going to be text, institution, that's going to be text, and then the year is going to be tiny int, which we learned is anything up to 255. Hopefully you all graduate grad school before your 255th year. Okay, all right, so next. All right, so once we've created the table, now we want to use the database to store our bytes. All right, so if I was going to populate my pet info table, I could run the following commands. So cur.execute insert into pet info. All right, so I'm specifying the table where I want my data to go. And then I'm specifying which columns I want to populate. So in this case, name, species, age, and favorite food. With values Rocky, who is my dog. He is 12 years old. And his favorite food is Bo Nana. Okay, and then my second pet, I can make the same call, right? Cur.execute insert into pet info. Again, name, species, age, favorite food. With values, my other pet's name is the 100 emoji followed by the flames emoji. He is a red panda, he's 2 years old, and his favorite food is bamboo leaves. Okay? All right. Column names do not need to be explicitly specified, but for clarity, this is typically preferred. And a lot of times, we haven't done this in this case, you have a running index for every single item that you insert into a database. All right, and you don't typically specify that running index. The database keeps track of that, which is why it's a good idea to specify the columns if you're inserting data. Okay? So for the next problem, all right, I want you to insert data into the table for yourself. I said the two people sitting next to you, but we're in pairs of two, so just do the other person that's at your table. And George, I'll come be your partner for this, okay? Yeah. Yeah.
So even though we did the exact same thing, so I the first time we ran it, it said yes.
So you need to click this in quotes.
But when we ran it the first time, it was error. Yeah, and then
It's like a string instead of a string.
You said you're at Northwestern, right?
The D doesn't equal this. It's not
And your first name?
yeah, that one just
Yes, got those.
yeah. Well, I mean,
And a few examples we have. I made it so now that you run the action, drop the table, and run the graph.
yes.
Well,
No, I mean, like, he was an 8th year grad student that I knew in undergrad. He wasn't close to graduating.
And did you do it yourself?
That's because he's like 40.
No, that might be fun.
commented that
I would have left long ago.
I'll be back in a second.
Oh, so I had run it with just the top one.
Yeah.
Then I re-executed the second.
So
my second one, and I'm curious to see if I have 3 instances.
I have no idea. I don't know if you would be able to count how many there are. You might be able to select start from. I've used SQL before, just not on Python. I've used it for SDSS.
Okay.
You can put that on the 12th year.
So I think if you do something like that, select star. That might just, it should just print it on. But I don't know when I can do that or not.
So, you can now do, when you go to folder, where you know
Or you have to do it inside of your cur.x.
Is there something wrong with it? Sorry. Yeah, there's something.
Probably like quotation marks.
Okay.
That's my least favorite thing about it. I want it to read my mind.
Yeah, it's just do what I want to do.
I'm not sure.
I don't know. Nope. That must just put it in stable, so maybe have it in print.
You can source your construct.
I've never done it before.
Just not in your memory.
It's in summary.
Yeah.
So it was weird, when I executed the next one, it was fine. Yeah, so even, yeah, no, when I executed the new one, this one page,
Oh, to display the results, run cur.fetchall.
it was fine.
That's in the next thing.
Okay.
So maybe it's not print.
Yep,
Yep, it's got 2 entries.
Okay. So I walked around. It looked like everyone got the information for their table in there correctly. So here's what the solution I wrote looks like. Again, this looks just like the example. So insert into DSFP students. In this case, I did my name, Northwestern, and called myself a 10th year. And I did Lucianne for Adler and called her a 13th year.
You're so kind.
Oh, is that? Okay. Fair enough. Okay. Okay, so now, all right, so now that we have some bytes in our database, we can retrieve those bytes with one or several queries. All right, and we hit this sort of ad nauseum during week 1, but the basics of building a query for your database are select, from, and where. Okay, so the select statement is telling you what information you want to retrieve from the database. All right, the from statement is specifying which table is actually being queried, and the where statement is providing conditions on which the query should happen. All right. So I think this is the final problem on this mini database that we've made. I want you to select this. This may return nothing since there's only 2 people in your database, but select the institutions for all students in the table who have been in grad school for more than 2 years. And then we didn't cover this yet, but to show the result of your query, you'll use the cur.fetchAll method. Okay? All right.
That's a close parenthesis.
So you want to say, so it's select and you can specify the information you want there. So in this case, we want which table.
Hey, cool.
I said sometimes you're like, it's a little easier to do, but you don't have to.
Just to kind of get the same feel as how to go before.
So this will select things, and then you just use this to print what you selected.
And where you specify. Yeah. You don't have to. They can run the same way.
So here, just the institution. Yeah, it should print.
Oh, that's
It depends on what you called it.
Yeah, that's what I call it, I think.
Sorry, you do need quotes though, around your.
Well, some of them just select Institution
That's fine.
until they select from.
So I have to select from.
Because you inserted it twice, but yes, yeah, you're good.
So that'll select all of them, but you want to do it for students for 2 years.
Question?
Yes. So that's the winner part.
Okay, Matt had that problem too, so the easiest way to do this is if you go back to the our GitHub page, I think that's that. Alright,
Then I have
click on
that
the
funny problem.
Because you've got 2 entries for me.
and then click raw here. Alright, and just copy all of this.
But you could probably do
Control A,
something similar.
Apple A. And then if you open a text file with wherever you have the
That gets you back to plus 2.
Oh,
no,
cool.
sorry, whatever text editor you use, Emacs or VI or TextNative.
So where
whatever.
is the condition? So when you're just putting up everything, you just selected everything from the table without any conditions.
Did you?
This doesn't even feel like I'm
Yes, so,
using Python.
so I read yours.
Because it's
You're
really
using
not.
SQL.
Yeah.
You're
Yeah,
just
just
using
paste it
Python
there
to do
and save it as the name of this file.
Okay.
In the directory where you're running your network. And then it should be working.
Yes, this is technically SQL type language, which is another programming language.
Yeah, it's very weird.
I had to learn some of these things to do like queries on SDSS.
I bet that's what we're gonna end up doing. Well,
Probably
yeah.
complex queries with SDSS.
Adam, I have a question.
Yes.
So I accidentally.
She added me twice.
Yeah.
So how do I remove?
So you can do, the way we created this table, I don't actually, I have to think about that really hard. The way we've created this particular table, I don't think you could remove one entry since they're identical. So normally, and we'll talk about this later, normally, like I was saying, you'd normally create a running index. So anytime you insert anything into the database, there's a column that essentially is just like ID or whatever. And then you could drop, basically, you could drop by the ID. But there's a command called drop if you want to get rid of individual lines or even full tables in the database. But I think in this case, if you said drop, you did her name and everything, it would drop both lines because they're identical.
Yeah.
Yeah.
But that's
So-
how you would delete a table too, right? If
Yeah, so you could drop.
accidentally
So you could go back
initialized
if you want, drop the table and re-execute all of those.
Yeah. So the way I fixed it before was that I just deleted the entire database and reran all my cells.
In this case, that's pretty much equivalent as well, since there's only one table in the database.
Yeah, so I guess it'd be
All right.
drop.
All right. So I think we're all through that. So just to wrap things up, I said so. Select institution from DSFP students where year is greater than 2. All right, and then cur fetch all, and with myself and my partner Lucienne, right, that selected both of us, which is Northwestern and Adler. Okay. All right. Now, before we move on to the slightly more complex problem, I want to appeal to the ACID properties of databases. Right. So this is essentially how many databases are judged in terms of their quality based on the ACID properties. This was first introduced to us during session 1. By Tomas. All right, and so the first condition in ACID is the atomicity. I said that right? Okay, which means that all parts of a transaction succeed. Okay, so if you have some complex transaction that's happening on the database, if that transaction does not proceed all the way to completion, then the state of the database is rolled back to what it was before the transaction was committed. Okay, and the example, the very good example that Tomas gave for this was, imagine you insert your ATM card, okay, you say give me $200, the machine malfunctions for whatever reason, the $200 doesn't come out, okay, you don't want the database, or basically the bank, to say, no, you got your $200, right? So that's the idea here behind atomicity. So we want to roll the database back if we don't actually complete everything in the transaction. Okay, the second condition is consistency, all right, and this essentially is just a question of, does the data always meet the validation rules? All right, so again, we're specifying the data types for the columns. Does all of the data in each of the columns actually match that? In many cases, that is strictly enforced, all right? The third condition, the I, is for isolation, all right? So we want no interference across transactions. even if they are concurrent. So you can imagine any sort of database that is backing a web-based application. There's going to be all kinds of people that are using that database at the same time. They're both adding data to the database, they're both running queries on the database, right? And we don't want these multiple users doing the same thing at the same time to in any way corrupt the database. This is actually a downside if you were to try to use SQLite with a bunch of collaborators. All right, this is not something that is particularly strong for SQLite, I'm pretty sure. And then finally, durability, right? So a committed transaction remains committed even if there's a power outage or something like that, right? So if there's been a commit on a transaction and so there's some kind of disruption to the database, when the database comes back online, it should finish that particular transaction. Okay, those are the asset properties. You look like you maybe want to add something, like I said something incorrect? Or?
No. But
no, okay.
SQLite is terrible at multiple writes to it.
Yeah. Yes. Yeah. Okay. All right. Okay. So now onto the bigger problem. All right. So we're going to do some complex queries now with SDSS. Right. So we'll come back. We'll use SQLite later this week. But now we're going to deal with SDSS. So all we've really done right now is create a small table, put a little data in that table, ask a very simple query of that table. All right. But normally a database has many tables. These tables are joined together via the various columns. All right, and this allows us to unlock some complex questions from the data itself. Okay, there's a link here. If you don't recall, you may need to check it. You may not. I think the hints are pretty useful in this particular exercise. But if you want the full SDSS schema, all right, you can get that by following the link. All right, but as I said, in this particular case, we're keeping things relatively simple. Okay. So everyone can just execute this. Cell Astro query, and some of you may need to install Astro query if you don't have it. But Astro query allows us to basically directly get an interface through Python to the SDSS database. All right. And so now the first problem is I want you to select 20 random sources from the photo object all table and return all columns in the table. All right. While this would normally be accomplished by, in many SQL languages, wait, I'm reading too fast. Normally you would start the query by saying select limit 20. All right, so that's just saying give me 20, return 20 things. Wait. Oh, I think on your notebook, this is out of date on mine. I have this incorrect. Anyway, what you want to do is select top 20 at the top of the query. I have a typo here on my slide, I'm sorry. That's what you need to do because SDSS uses Microsoft's SQL server. Okay. All right, so it's going to start select top 20, and then you can go from there. All right, and at this point, if you like, feel free to move ahead. You can try to complete all of problem 2 in the next few minutes.
I don't know if you need quotes. I don't know. Looks like it.
Oh, I see. Okay. Very odd spacing.
Yes, sorry, yeah. We've used Astro query in each of the previous 2 sessions, but if you changed your creating an import.
Before we were. What's my smiley? Yeah.
Cool.
Yeah, what's my
That's really
smiley?
cool.
And then we wanted it to really helpful.
Oh, okay.
I need to learn to use this.
But when we did the.
Because I've tried querying SDSS before. It's no fun. So you don't need to do.
I just copied the
So you won't need the
Have to download all the packages.
parentheses.
Yeah.
And technically you can just break things in there.
But it looks like you didn't do it because you
Yeah.
said
And
you
if you just
executed
start
it
it selects all
The second
columns.
time.
So I don't know what error was the first time. But yeah. No.
But you do need the quotation marks.
Yeah.
Asterisks.
I don't think
reason you're getting there is that there's no columns down. You don't have to. That means it's
Yeah.
So you want to select top 20.
$29 top to say.
Okay. Can I do like lowercase?
Yeah, you can.
Okay, so you have not
But then do
specified any
space asterisk. And I'd be careful about mixing uppercase and lowercase because I don't know what happens
I
there.
did not, I should have put that in.
No, I didn't.
Okay, just close it. Center.
You're fine now.
It should just print it. Yeah.
I think the harder queries I think are going to be.
So that's 20.
That shouldn't happen for this one. You don't want to
So not info object.
Yes. Yeah. Which is why the scanning browser is nice because you can figure out where you actually need to do some of those things.
Yeah, you would, you need to do a con dot No curve. You're just committing.
So is it, just take the top right?
You should, if you've already finished this, you should just move on at this point. Right, we're just trying to get through problem 2 right now. I'm walking around as people have questions. Yeah. Yeah. Yeah, so in the join you're specifying that I want things from both tables. Okay. And then I'm going to show you a quick shorthand. So oftentimes you can, so the full syntax would say from photo object alt as, and then you can basically rename that table. But you actually don't even need to do that as. So what most people do is they would say photo object alt key. Okay, and then all these photo object alts that you have here, they can be kept out. But then also in this particular query, if you don't have columns that are the same across the table, you don't even need to specify the table. So basically the SQL, because I select C model and view that doesn't exist in spec all. So you don't even need to, in this case, specify. As things get more complicated, I would say it's a good habit to be in. So that it just improves the readability of your query. You go back and look at what you did, but yeah, in that case you don't have to. Okay, so I'm still walking around. I'm going to put the solution up for this in case anyone wants to take a look. Okay, and I'm still walking around. Just continue working and answer your question.
Is that asterisk? Yeah, asterisk. So does that make sense?
Yeah.
So we're trying to do this.
And then you specify what is the column on which you're joining. So you say on, and then you say,
so you can just say photo object all dot object. Yeah, and then at the end of that equals step object call. And best object ID is the column instead of the row.
What do we want to join? So we want to join photo object with spectral.
No, you didn't. No. So you're
Yeah.
you don't have that for this. You just want to.
Where?
And then we also want you to get the class, which comes from the spectroscopic tables. You need to add that column as well. At the end of your columns you're asking for. And then you have to do that. Right, and then you see you get boxes and stuff. Maybe some flavors. Yeah, so now you need to show your name joining these two tables, then you need to specify what column you would like to join that. So here you can say column, you can say photo object all.
No, that's guys, it's fine.
Because when I just moved up the
Equal.
yeah, so there's those, but if you read the step 2 and then yes, it needs to do this thing on the back here. That's the way you do it.
You know, this is we want to your best object all. And then you miss one from two, that we want to get the view go back up. We also want to get the class. So we need to add the class as one of the things we're selecting on the table.
Yeah.
So this is how we're getting information. So you can see, this is what the Thomas tree source is, and then vectors copy classes.
These aren't spectroscopic doll. You have to join on to throw out a doll to get the doll.
I'm not only like getting my one database.
The order doesn't matter, but spec object all does not have an object ID.
Right, but these aren't columns. These aren't photo object dolls. And then you combine
Oh,
them
I
by-
need to find the okay. I guess my mouse.
Yeah, if you have a catastrophe, you can try to run it there. Then I have the actually same problem. I only got that to run in catastrophe. So it's a query on catastrophe that takes like 4 seconds. But for whatever reason, it's in the web interface. It's the time off. I don't know the answer why. I can take a look into it.
No, I just have this different credential.
This was the okay, so then there's left join. Okay, yeah, left join and right join. All right, so we're actually a little bit into our break time, so I'm just gonna quickly go over the solutions here. If you didn't get all the way through, that's fine, right? This was mainly meant to sort of jog your memory. Okay, so all right, so as I said for the previous problem, rarely do you actually need every single column that's in a table of a database, especially something as complex as like the Sloan database or the eventual LSST database. So typically instead we want to specify specific columns, and often we want to join tables together. All right, so this is what the next problem was. Okay, so the first thing is we just want to do an inner join, or people often just call this a join. That works as well. And we wanted to select things from both the photo object all table as well as the spectroscopic class from the SDSS spectra. Okay, and so, right, so here's the solution I came up with, which was just to select the top 20 object ID, C model mag U, etc. through Z, as well as the class. Okay, so that's what we're pulling from the spectroscopic table. and then from photo object all, which I'm declaring as table P, inner joining to spec object all, which I'm declaring as table S. And then after saying the two tables we want to join, we have to specify which columns we're going to use to join the table. So in this case, we're connecting object ID to best object ID from the spectroscopic table. Okay, these solutions will be posted very soon. I don't want to eat too much of the break time, so I'm not going to pause to let everyone write this fully down. Okay, all right, and then the next problem was to essentially do the same thing, but instead of an inner join, right, we're going to do a left outer join or left join to remember how those work. Okay, and if you scroll all the way back through your history in the Slack channel, you can see a nice visual representation. Or if you just Google inner join, left join, right join, you can find nice figures that sort of explain how this works. Okay, so in this case, oh, the results aren't fully showing, which is not that helpful. But so in this case, we've done a left outer join on spec object all. So what that means is we're selecting anything that's available in photo object all. And then if there is corresponding spectroscopic information, right, the left outer join takes that spectroscopic information. But if there is no spectroscopic information, then we just get a null. A null is returned. And I'm sorry that the full table results aren't shown at this zoom. Okay, so that's what happens with the left outer join. All right, and then the next problem is essentially the same thing, except we do a right outer join. So in this case, we're going to select everything from the spectroscopic table, as well as any corresponding information in the photometric table, should that exist. Okay, and here is the solution to this particular query. And so in this case, you'll see that there are many sources for which we can actually get spectroscopic types, but they don't have a corresponding photometric detection, right? Which is why we've got null values for most of the photometric returns in this table. Okay. All right. And then finally, we closed with a challenge problem, which probably you ran into timeout errors if you got this far. Okay, but the basic idea here was to try to identify bright AGN that Sloan maybe did not manage to get a spectrum of. All right, and so the way that we were going to do that is by cross-matching against sources that are detected in the ROSAT satellite. So that's an X-ray satellite. So if you have a source that's bright and it's got X-rays and there's no spectrum, there's a chance that that source is in fact an AGN. Okay, low redshift AGN as well. So here we wanted to create a nested query, all right, that retrieves all ROSAT sources that don't have an SDSS spectrum. So the way that we define bright in this case is we add the flux in all bands, right? So we don't want to pick a specific filter in this case because some AGN are red, some are blue, all right? So we just add the flux in every band and make sure that this is above 10,000 nanomaggies, which is a unit that is only used by Sloan. And then we're going to set the photometric type to 3. That means we have an extended source, which we would expect for a low redshift AGN. And then eventually we join against the ROSAT satellite. Okay. And then I'm going to quickly put up my solution to this problem. Again, this timed out for me, so if you got this far, you probably got timeout errors. Sorry about that. So I'm going to select everything from the ROSAT satellite table. And then in this case, I wanted to specifically do a nested query. So here the nested query is to get the RM table is one that I've created. So I first do a query to get some of the properties from the ROSAT satellite, as well as the photometry from the photometric object table joined on the ROSAT table, where we match the condition on the bright flux and the photometric type of the object. Right? So essentially, I've done a single query here, but then I also want to join the results of that query, right, to the spec object all table, where I do a left join, and I require that the best object ID is null in the spec object all table. All right. So that this last condition here essentially specifies that when I've done the join, there is no corresponding spectroscopic object to the bright X-ray sources that we found in the first portion, the inner portion of this nested query. Okay, I said all of that very quickly. All right. But we're in the break, so I'm going to now ask if there are questions, and I will post all these solutions so you can take a look very shortly. All right, no questions? All right, so then